Hello students, in this video tutorial I am going to explain you on the concept called designation of bearings. There are two ways of designation of bearings. The one is whole circle bearing system, that is in short WCB, which can also be called as azimuthal system, and the other way of designating a bearing is quadrantal bearing system, that is a QB, or it can also be called as reduced bearing system. Coming to the first one, that is a whole circle bearing system. Here in this system we are going to measure the bearing of a line, from the magnetic north towards the line. Wherever may be the line may be first quadrant, second quadrant, third quadrant or the fourth quadrant. In whichever the quadrant the line may be, we are going to measure the bearing of that line from the magnetic north. Okay, here the bearing varies from 0 degrees to 360 degrees. Our prismatic compass is under this kind of bearings. You can find the bearings in the prismatic compass like the whole circle bearings. You can find the whole circle bearings in the prismatic compass. What I mean to say is that in the prismatic compass there will be a 0 degrees at the south, 90 degrees at the west, 180 degrees at the north, 270 degrees at the east and 360 degrees at again south. You can find the variations of angle from 0 to 360 degrees. That what I am explaining now with respect to the whole circle bearing system in the prismatic compass. Okay. See in the present figure, you can find the four lines. Line AB, which is there in the first quadrant. If you call up this quadrant as the first quadrant, this as the second quadrant, this as the third quadrant, and this as the fourth quadrant. The line AB is there in the first quadrant. So, as I told you before, in order to measure the bearing of a line in the whole circle bearing system, we have to start measuring the bearing from the magnetic north. Correct? So, for the line AB, what is the bearing with respect to the whole circle bearing system? It is from the north we are going to measure, that is a theta 1. So, bearing of the line AB is theta 1. You can find the line AC, which is there in the second quadrant, whereas the bearing of the line AC, as I told you before, we are going to measure the bearing from the magnetic north always, that too in the clockwise direction. Okay, see the bearing of the line AC with respect to the magnetic north in the clockwise direction is this angle from the magnetic north towards the line, that is the angle theta 2. Here we are having one more line which is there in the third quadrant, that is the line AD. Here also with respect to the measurement of bearing of the line AD, we are again supposed to do the measurement from the magnetic north towards the line AD. See, our line is there in the third quadrant. From the magnetic north towards the line, that is this angle. This is what the angle theta 3, and the last line, the AF, which is there in the fourth quadrant. Again also with respect to the line AF also, we are going to measure the bearing of the line AF from the magnetic north itself, that too in the clockwise direction. This is what our whole circle bearing is. Okay. So, see here from magnetic north towards the last line AF, that is the angle theta 4. Okay. So, the bearing of the line AB is theta 1. This one. The bearing of the line AC is, see this one, theta 2 from magnetic north towards the line theta 2. The bearing of the line AD, that is from magnetic north towards the line AD, that is theta 3 AD, that is theta 3. Coming to the last line AF, with respect to the line AF also, we are going to measure the bearing from the magnetic north towards that line AF in the clockwise direction, that is, see here, This is theta 4. A, F, that is theta 4. Okay. Like this we have to measure the bearing of the line with respect to the magnetic north towards the line. In whichever way the quadrant the line is situated. Okay. See here in the first quadrant our AB line was. At that time how to measure the bearing of the line AB? It is simply the theta 1, that is from the magnetic north towards the line AB. If the line situated in the second quadrant from the magnetic north towards the line, that is this angle theta 2. If the line situated in the third quadrant from the magnetic north towards the line which is there in the third quadrant, that is our angle theta 3. And the line situated in the fourth quadrant, that we are going to measure the angle from the magnetic north towards the line, that is the line AF, that is our theta 4. Like this we can measure the bearing of the lines in the whole circle bearing system. This is what about the whole circle bearing system. Coming to the quadrantal bearing system, which is simply called as reduced bearing system also. Here the bearing of the line is measured with respect to north or south, okay, and also with respect to east and west. What I am supposed to say is, what I am saying is that here the bearing of the line is measured eastward or westward towards the north or south, whichever is nearer. If the line is nearer to the north, we are going to measure the bearing with respect to the north. If the line is nearer to the south, we are going to measure the bearing of that line with respect to the south. Okay, see here the line AB is there in the first quadrant, and also keep one more point with respect to the quadrantal bearing system in your mind, that here the bearing varies from 0 degrees to 90 degrees, whereas in the whole circle bearing the bearing varies from 0 degrees to 360 degrees. Here in the reduced bearing system the bearing varies from 0 degrees to 90 degrees. Okay. See here the line AB. What is the bearing of the line AB? As the line AB is nearer to the north, so the bearing, the designation of bearing would be north, that angle, and towards east, it is east. Okay, this is what with respect to the AB, correct? Let us take up the bearing of the line AC. So the bearing of the line AC becomes, as you can see, the line AC is nearer to the south and it is there in the second quadrant. If the line is nearer to the south and if it lies in the second quadrant, the designation of the bearing will be like this: south, angle beta, east. Hope you are getting that what I am saying. Coming to the next line, that is the line AD. Here the line AD lies in third quadrant and the line AD is nearer to the south. So how could we designate the bearing of the line AD now? For the line AD, the designation would be south, as it is nearer to the south. Angle, the angle is theta towards west. Likewise, we have to designate the bearing of the line. Coming to the last line AF, designation of the line AF is, as you can see, the line is near to the north. If the line is nearer to the north and if it lies in the fourth quadrant like this, we can designate the angle which is there in the fourth quadrant in this way. As it is nearer to the north, the designation would be north. The angle is phi towards west, so west. Likewise, we have to do the designation of the bearings in the reduced bearing system. Okay, our survey's compass. In the survey's compass, you can find the designations just like what I have wrote in the board. That is from 0 degrees to 90 degrees. The designation varies. You can take up the example of the survey's compass, where in the survey's compass you can evidently see the variation of the bearings would be from 0 degrees to 90 degrees. Yes, this is all about the reduced bearing system and this is all about the whole circle bearing system. Yes, this is all about this video. Hope you have completely understood this video. Thank you.